welcome back to Gettobyte YouTube channel once again. Continuing our automotive technology series, from this video we are going to start with autosar technology. We will be starting with hands-on activity and skill-based learning on autosar technology using MCAL Layer. Before proceeding further, I will highly recommend to check out my series on automotive playlist and the microcontroller series so as to get the prerequisite knowledge and basic understanding about the things that we are going to start with further. Now let's just get 1 minute understanding of the different terminologies which I have just now stated. First is AutoSAR. AutoSAR is a software stack of which has been standardized to write software in microcontrollers for developing different automotive embedded systems. And AutoSAR is an architecture of different software layers to make the final application independent of the electronics that is used for developing automotive applications and subsystems. Now let's understand the MCAL layer terminology. MCAL layer is the closest layer to the microcontroller and it is kind of like real-time drivers RTD for all the peripherals of the microcontroller in AutoSAR software stack. Using this layer only, embedded application software for automotive vehicle is built. To know what kind of automotive applications are there, I will highly recommend watching this video. Now, what AutoSAR technology has done is whatever automotive embedded application you want to develop, the RTD real-time driver files that will be needing to develop that corresponding application would be same irrespective of microcontroller that you are using, whether that microcontroller is of NXP and Renesas, Infineon or etc. So those who don't know what RTD is, real-time drivers are software stack in microcontroller world to use the microcontroller peripherals. And in automotive world, these real-time drivers are being referred as MCAL, microcontroller abstraction layer. So each microcontroller company has to make the real-time drivers of their microcontrollers up to MCAL standard that has been stated by AutoSAR technology to make their microcontrollers used in automotive applications. And this is what we are going to do. If we are going to use the one automotive microcontroller and use the MCAL layer of that microcontroller to develop different automotive applications and understanding the peripherals of the microcontroller. MCAL layer is not available for every general purpose microcontroller like Arduino, ESP or STM32 based. MCAL layer is only available and is stated only for automotive microcontrollers. So first thing that we'll be needing is to have a automotive microcontroller and its development board readily available and easy to use so that we can use that microcontroller and development board for making DIY projects or for practical learning on the MCAL layer. And here comes the electronics version 2 development board, which is based on automotive microcontroller NXP S32 K144 and it has its full MCAL layer also freely available. So in terms of the hardware, we will be needing electronics version 2 development board, which is based on automotive microcontroller for using the MCAL layer of it. And the J-Link V9 debugger, which is an ARM-based, which is a debugger to program and debug the ARM-based microcontrollers. And in terms of the software, we will be needing an MCAL layer software stack that will be available from NXP website and an IDE integrated development environment onto which we can develop configure and make our custom application codes using MCAL layer. And that IDE that we are going to use is NXP S32 Design Studio IDE. So NXP S32 Design Studio IDE and the NXP MCAL layer support is freely available that we can download from the NXP website, and that we will be navigating in the upcoming minutes of the video. And in terms of the hardware, electronics version 2 development board and the J-Link V9 debugger is the only two things that you will be needing, and these two things are very much affordable in terms of the actual development boards of automotive that are there in the market, and these are easily available in the from the Gettobyte website, for which the link is in the below description. Now let's just explore and see that how to set up the MCAL layer and S32 Design Studio IDE and how to configure different peripherals of microcontroller via MCAL layer in S32 Design Studio IDE. I hope you guys have installed the S32 Design Studio IDE. I will not be navigating the installation process in this video. The installation process for installing the S32 Design Studio IDE can be checked out from this video in which I have properly explained the proper installation process step by step. Now to install now after installing the S32 Design Studio IDE, you will be seeing the home page or getting started page like this. Now we will be needing an MCAL layer software stack for our microcontroller, for the S32K14 for microcontroller that is there in electronics version 2 board. So for that, navigate to NXP website and search S32K3 standard software and press enter. After that, you will be navigated to the this link and you will be seeing that there is a RTD real-time driver. Click on its download and click on real-time drivers for S32K1 and click on download, and make sure that you have signed into the NXP website, okay, and with your login credentials, and anyone can log in and register to it. Now after that, you will be see a design center flexnet operation page like this. Click on S32K1 real-time drivers for Cortex M, and in that go to the latest release of MCAL layer by NXP for the S32K1 microcontroller is 2.00 version. So click on that thing, and then we are going to download the exe file of our S32K1 MCAL layer RTD files in the update site. This update site would be used in our S32 Design Studio ID for configuring for this integrating the MCAL layer with the Design Studio ID, and exe will be downloading separately in our PC for our understanding purpose. I have downloaded both the things. You can just download it from here. Okay. And in the downloads, then you will be able to see there are two exes. Okay. Update site and the RTD 2.00 exe. First of all, let's just download that exe. Okay. It will be asking, it's a simple installation process. Next the RTD files of the MCAL layer would be installed at this location. Click on next and click on. Right now we are not. I'm not dwelling into the EB resource part that I will be covering in the another video. So for time being, you can just leave it as install. Okay, without any path, and now we'll be extracting it. And after that, you will be able to see. If you will go to the C NXP, and here you will be able to see this is just now right now created, and our installation process is happening. Okay, so this is the exe that now that will be installed in your PC, in which all the MCAL layer of all the peripherals of the microcontrollers would be available. Okay, now for integrating this MCAL layer and software stack with the Design Studio IDE, what we are going to do, we are going to go to help and go to install new software. And after that, a pop-up will come in which we are going to add and go to archive and select the update site package that we have just now downloaded. Okay, so click on this update site, the zip package, update site zip package. Okay, and click on add, and it will be showing that what all software stacks are there in this zip package. Select all and then click on next, and then it will be taking some time, and just follow the simple installation process to complete it. Okay, so by this way, you will be by doing this update site way, you will be able to integrate the MCAL layer and the Design Studio ID. So after the update site or the installation and its loading, you will be see that its installation is done, and a restart of Design Studio ID would be asked for. And just click on restart now. And after installing the update site package, you will be able to see that in the NXP folder, the Design Studio 3.4. Okay, navigate to the design listed to DS and software, and then you will be able to see here S32K1 this platform SDK. So this pack folder would be installed, or you can see in this folder location after the successful installation of update site, in which will integrate your MCAL layer of all the peripherals, and their documentation and files would be available from here. So this is what you are going to see in the after the update site package successful installation. And after the exe successful installation, you will see that in just NXP folder, the separate design, the MCAL layer whole package is also installed, and that we can use for our understanding and the learning purpose also. Okay, now after the restart of the Design Studio, it will ask for the workspace. Click on launch, and it will might just take certain couple of minutes to load. Now, after restarting the Design Studio ID, after updating with the update site of the MCAL layer S32K1, go to the help and S32 Design Studio extensions and updates. And by this, we will first check that okay, our MCAL layer configuration and settings is integrated properly on our Design Studio IDE or not. So it might take couple of seconds, not couple of seconds, but couple of minutes to load at first time after restarting the Design Studio IDE. Okay, so now go to the installed and search for the S32K1. Okay, so if you see that there are these are the yes S32K1 RTD autosar 4.4 and these are installed, so it means that your installation process is fully done for the MCAL layer. Now what we are gonna do, we are first of all open new we are gonna open the example projects of the using the M of the MCAL layer. Okay, and then I am gonna show you how to make a project from the scratch in the next video using the MCAL layer. So for opening the project examples for the MCAL layer, go to the S32DS file new and S32DS project from example, and then it will be loading. Okay, and after here you will be see that there are the this S32K1 AutoSAR 4.4 example projects for all the peripherals. We can see there are example projects which are built on the MCAL layer of the corresponding peripherals for the S32K1 family. Okay, so we are first of all just in this video, I will just quickly navigate you through by opening the digital input output example project and finish. Okay, after that it will be loaded into your this perspective and the Design Studio ID. To know more about more Design Studio and how to use it and all these things, check out this following video. Okay, and double click on the Design Studio, the project which is opened in your project explorer. Okay, and click on the .max file. Over the .max file, you will be able to configure all the peripherals of the microcontrollers, all the AutoSAR this code configuration tool for the MCAL layer will be visible to us. Okay, so it might take couple of seconds or couple of minutes to load at first time. You just click on OK. Okay, if this warning comes up, and after that, okay, so your .max file is loaded. Now after that, go to the peripherals to this tab to the this peripheral icon, and here you can see MCAL layer, and over onto which there are different modules of the MCAL layer would be visible to you. Just click on the update code at first, okay, and it will be updating all the .c.h files according to the MCAL standard, okay, and after that these red errors would be gone. Okay, and in the bottom left you can see the update code is happening. Okay, click on it and it will show you the update code process is happening and operation in progress. All the files were updated. Okay, and you can see now here all the red arrows are gone. Now, if you click on any of the MCAL, this is the example on DIO example. So corresponding digital input, output, and modules of the MCAL layer are configured in the example project, and we can configure and play with these different peripheral configurations and these things. Don't worry, we will be navigating to the each peripheral of the MCAL in the subsequent videos. This is just the getting started and basic understanding about on how to set up the MCAL layer support on the Studio IDE. Okay, yes, after we have successfully updated the code, now we can navigate back to our project, and by clicking on this icon on the top, you will be directed to the previous view in which you can see your project folder open on the project explorer, and all the .c.h files of the MCAL file of the MCAL layer for the corresponding peripheral would be generated in the generate include and generate source files. Okay, so these are automatically now generated. Now, one of the benefit of using S32 Design Studio IDE is that we have not only configured and generated the MCAL files for the peripherals, but we can compile this code now also. Okay, so in the project explorer on the folder structure of your project, you can see there will be a source file folder, and under which in the main.c file, you can see the main application code that is built using the MCAL layer, okay, of the DIO peripheral by using the DIO peripheral. So it's a simple main loop. Okay, while loop. And to see the what does this example do, you can click on the description file and get to know about the example use case. Okay, now for building the project, you can also build it directly from here. Click on it, project, and build your project. Okay, now on the console you will be starting to see your project has started to build. Okay, and all the files are starting to build, and on the console you can see the final output, whether it is of zeros, the errors and warnings. And in your project explorer, in the folder structure, you will see there is a debug flash folder which is created, which will be containing all the output files of your code of your project. So it will be having the .l file, .o files, and all the linker files of the object files, basically not linker files of your project. Okay, and yes, now it is being compiled successfully. Your .l file is generated with zero errors, zero warnings. In the debug folder, you will be able to, so just click on the refresh, and you can see the .l file will be reflected over here. You can see from here. So you have seen that how we can open the MCAL layer examples on the Design Studio 3.4. Okay, now you have successfully compiled your MCAL layer example project. Okay. Now to flash this L file, you can that also do from the same ID, from the S32 Design Studio ID. So you can see that how easy it happens for us to develop on the MCAL layer development on in a single integrated IDE, S32 Design Studio. We can configure the MCAL layer, we can build the MCAL layer based example project, and now we can also debug and flash the project. So for doing so, click on the project, go to run, and click on debug configuration. After that, a window will pop up. Now we are using, as you can see in the screen, that this is our hardware. Okay, this is our electronics version 2 development board, and this is the j-link v9 debugger that we have connected with our electronics version 2 for it programming and debugging it. To know its connections and what are the connections and how do we do, I will recommend watching this video in which I have in detail explained the step-by-step connections for connecting the electronics version 2 with j-link v9 debugger. Its link will be available in description, below description link. Okay, now in the this debug configuration window, click on the Segger GDB J-Link debugging, as we are using J-Link V9 debugger, and click on the plus new configuration. Then a new configuration would automatically be generated of your project. Okay, and all the configurations would be done by default. And in this, you can see the debugger configurations, startup configurations, and all these configurations. Keep them as it is, which is in default. Now click on the debug. Make sure that you have connected your J-Link V9 debugger with your PC, and your controller is being powered up. Okay, and I will debug, and then it will start the debug configuration. Okay, now you just can see in the okay, so it is showing us here that we have to fill in the device name. So there is one setting that we have to do, and that setting is you go into the debug configuration again, go to the debugger, and in the over here in the device name, write the main of the microcontroller that you are using. So we are using S32K144, so that is our device name. Click on apply and go on debug. So again, your debug configuration window will come up. Okay, and you're launching for debug configuration flash, debug configuration folder, starting the server, launching the server for the GDB server for connecting with the J-Link V9 debugger, configuring GDB. In this guy, it is asking to open the debug perspective. Click on switch and click on remember my decision for future things. Okay, and now you will be directed, your code is being flashed onto the microcontroller, and your debug configuration is being opening. Okay, and you will be able to see in the debug perspective, like all these things, how to debug the controller and how to flash on it. I've explained in detail in my previous videos of Design Studio ID only. So yes, so yes, now you can see your program is flashed onto it, and you can now debug it. It is stopped at the main.c five main in the main, and if you go on the go, so you will be able to see on the controller on the hardware your LED start blinking, and that's what this simple MCAL example do. It just input and output ST high and low onto the this channel 15 of the pin 15 of the microcontroller. Okay, so this is the simple demo example. In this video, we have got to know how to configure how to set up the MCAL layer onto your Design Studio IDE for your learning of AutoSAR technology using the MCAL layer. And on the Design Studio, we can configure all the peripherals of the microcontroller of using the Design Studio IDE code configuration tool. Okay, so now in the upcoming videos and in the future things, so yes, so you can see over here it is ADC, CAD, all the peripherals we can select. Okay, and their MCAL configuration would be automatically generated and would be can be configured, and we can make them. Okay, so that's it for this video. Okay, now in the upcoming videos we are going to start first of all with the MCAL GPIO so peripheral and its corresponding modules that are there for the controlling the pin input and output, and peripheral by peripheral we'll be controlling all the MCAL layer peripherals and understanding its demo use cases and creating its demo use cases for on our own also. So that's it for
So
now.
that's it for now, guys. Like the video and subscribe to the channel, and do share it among your friends, and press the bell icon to get notified with such videos as and when they are uploaded.